You figure out how many is that? I know it has. You don't have. It's on there.
It's like this point.
We're working on the warm up.
But isn't it odd? Yeah, no, it's just because I thought it was that odd if it's the number of petals in there, and if it's even, that's 2 times.
Oh, audit even too. Look at this one.
Yeah, that's different.
Negative, what do you want? You go to the back, so like you find the angle, and like, yeah, that's exactly. Well, it should have 8 petals because there's 4. Like, well, because like, for this one, the first is from 0 to 0. Or yeah, so like, whichever way, like.
Yeah, I just like do this. I did one time this on this round.
Oh my goodness.
Yeah, so.
Well, cause like,
there's-
at 0, like you don't really like need. It's like,
You go, die.
Gratitude experience.
Well, this was like.
But I don't, yeah, I like, you go like here,
Oh, my
and then you go right back.
I'm just gonna grab this.
And so.
Yeah, because then you always start at the origin, right, like, it's like your first place, right, and then you go to 0, like, at the beginning, and then you go out. So then you like go this way. Cause like now pi over 8 is the angle, but you're moving like 0 spot, so you lose that for life.
So I understand.
Again.
That's not like.
Yeah,
Let's grab.
Yeah, if it was 0 negative 3.
Look at those. Oh, I forgot.
It's 0 regular.
Since I lost, should it be very unfair?
Oh, is there another one over here, maybe?
Yeah.
Oh, I'm sorry, 734.
Oh, okay.
Yeah,
Great.
thank you. Good catch.
Just like make.
It has-
So like whenever they're at.
Oh, it usually go like this, since it's 3.
Are we about ready?
Mine's a little.
So they don't overlap. What?
Did she
Yeah,
do that?
well, like,
Okay.
okay, wait,
Okay.
so like.
Mine's just.
Right, it's like. Wait, but you know, I feel like, do they overlap like in here, right? It's like, if you, whichever.
Yep.
You go, like, you reach this, right? Then you have to go to the angle, wherever you're like moving, right?
Because then it wouldn't be accurate. Our drawings.
Yeah, even though from here to start is 1. Then you have to get from like this one to negative 3 pi.
That's like I.
So like,
So I
then you
think-
like pi refers this one,
Yeah.
and then you go backwards 3 on. So you'd go like 1, 2, 3, and so so it's like yet another,
Like.
but like on the pi report.
It's not gonna work.
Super double competition.
Let's just go on.
And then.
Then I don't know, or 0.
I mean, small.
Yeah.
Bigger.
And then pi over 2, comma.
Just another few seconds
It's
on
like-
number 1, and then get to number 2.
And then you go up 3.
Oh, does anyone else have test corrections to hand in? Thank you for those of you who have them. Get them in when you can.
It's not for this quarter.
It's such a small part of your grade. I wouldn't stress it.
Huh?
I don't know.
Then you're fine, yeah. You're gonna need to open for it to come down, so then it's just not up your head. Yeah, and then you come down. But like, I don't have that one. Look, it just like continues and then like I'm pretty sure it's fine. Okay. Well, you're like, you're yeah. No. It's just our whole radius. Yeah. Because once it fills once, it's long. So then it's just like a label, like you put it on the hub. It's just like, yeah, I don't, yeah. Shouldn't ask.
Okay, please move on to number 2 if you haven't already.
And nor did yeah. Yeah, like, you just like,
It's just.
oh, because the origin. Yeah. Oh, wait, no, I mean, yeah, radius.
Okay.
We could somewhere, yeah. The origin 0, 0, yeah. Like, literally. You just talk a lot of it. Don't feel weird, I feel like different things. Oh, I don't.
Is everyone finished with number 2?
Oh, no.
So if you haven't got to number 2, please go ahead and just skip to it. And
I think it happens so. I tend to be this.
Wait, so that's graph.
Oh, I've seen this. I'm assuming. Can I have plenty?
oh, sure.
Oh, sorry. Wait, I got it. Would you just?
Or wait, 16.
Okay, ready or not? Let's do it. Your attention, please. Now it seemed like when you saw the equation, you already knew what shape it was going to be, didn't you? You knew it was going to be a shape called a rose, and that rose would have how many petals? 8, and you know it'd be 8 because it's even, right? So that 4 theta gives you 8 petals, but 5 theta would give you 5 petals, which is kind of interesting. Okay, so yes, Levi.
I think it's just the same, but last question we did, I think we only did sine roses.
Okay.
It's just the same for cosine results, where it's even and stuff.
Did we do cosine?
Yeah, it's just, yeah, that's for what.
That's when you.
That's what it says.
So I do want to talk about this, like getting it from the helper graph to make sure we can connect from the helper graph to the polar graph. But ultimately, your goal is to do things as quickly and as efficiently as possible. So let's just talk about what the essentials are that you need ultimately to get that 10 out of 10 on the test. Are we going to have a test this unit?
It's a project. It's a project.
It's like a more of a kind of a project that's going to be done in pairs, right? Partners. Yeah. Okay. I think it's February 11th is what you're looking at. February 11th. Yeah, Holden.
Project gonna still like, it's gonna be like the magnified test.
Magnified test? Is that what
Like every test is working.
oh, is it going to be increased in value? Good question. I believe it is. I think we're still doing that. But you'll have support here from your neighbor or from your partner, as well as, did she say anything about technology use that you could, Desmos, calculate it too? Wow.
Wait, so it's gas partners.
It's yeah, the partners. In any case, let's do this. If I'm going from a helper graph, I'm going to start with a period that is how big? Pi over 2. And then I'm going to split that pi over 2 into how many pieces? 4. You always split that period into 4 pieces. So I know that the amplitude is 3, -3. So it's cosine. Does this either go with what you wrote or what was in your brain if you're making a helper graph? I hope so. Otherwise, I have some questions for you. Like, where were you? Okay, and if I want to label this x-axis, which is now honestly the theta axis, isn't it? And this is r. But we're thinking about it in rectangular form. How should I label the theta axis here? I take that pi over 2 and then cut it in half to get pi over 4, and then I'll cut that in half again to get pi over 8. Okay, and then that last one is 3 pi over 8. You guys are so good at counting. That's great. Yeah, 1 pi over 8, 2 pi over 8, 3 pi over 8, 4, etc. So we're working the first quadrant only. I'm going to cut this in half. I've pre-made a circle since the only radii we really care about are 8. This is a circle that is either radius 8, or we can think about it as radius -8, can't we? Which is a little strange, but considering polar coordinates are radii that are negative should make sense. So my first thing that I'm going to analyze is from 0 to pi over 8, where the radii go from 3 to 0. I know I said the radius is 8, so the radius is 3 or -3. Excuse me. Where did I get that 8? I don't know. Tripping. Okay, so from here, I'm just going to go to this. And I have to stay in that sub. Yes? Now, the next sweep will be from pi over 8 to... I'm actually going to go all the way up to 3 pi over 8. Right, so I'm going to go from here to here, where the radii go, look at my helper graph, pi over 8 to 3 pi over 8, the radii go from 0 to -3 to 0, is that right? But since they're negative, I'm not going to see anything in the first quadrant. All those points will be seen in the third quadrant, specifically in the sector that is vertical to that in which I'm looking. Does that make sense? So I need to extend this a little bit. Need to extend this one a little bit. And I'm ultimately going to reach this. So pi over 8 to pi over 4 to 3 pi over 8. Yes? And finishing off what we've done so far with a single period, I'm going to go from 3 pi over 8 to pi over 2, where the radii increase from 0 to 3. And I hope you all are here. Radii are increasing from 0 to 3 in that little sector from 3 pi over 8 to pi over 2. So right in here, it's going to do this kind of thing. Yes? Any questions? I want to play with your mind just a little bit, and I want you to see a cosine wave in what I just drew as that axis turns. Do you see it going from 3 to -3, then up to 3 again? Think about it, just like this first one, if you were to slide along the x-axis, 3, 0, -3, 0, 3. Do you see the same thing here? Cosine 3, -3, up to 3. It's just interesting to look at it a little differently. Am I done? Heck no, I'm going to continue just a little bit because 8 is just far too many to do together. But I think just doing what we have so far puts us in the right direction. So I will go up to, what is this, 5 pi over 8. And I really like to take all the positives together, all the negatives together. So I'm going to think about 3 pi over 8 to 5 pi over 8, where the radii go from 0 up to 3, and then back down to 0. That was poorly done, but good enough. Then after that, in my next sector, they're going to be in here, I believe. I'm going to go from here to here and then back, etc., etc. I think that I am now here. And I think I'm halfway done. So now, again, this analysis, you could do it. It's a little bit painful to take chunk by chunk by chunk, especially for this much information. So it's up to you to get the information you need. In other words, it's an 8-petaled rose. And it's up to you to know where those petals are. I hope it makes sense that cosine begins on the axis, whereas sine would kind of be tucked in off the axis, that what we call the x-axis. And I hope that's helped for any of you who are a little bit iffy about the roses and the polars. If you're unsure about what I've done here, if you're thoroughly confused, make sure to get some help. I'm happy to help you out. During conference times, before schools, after schools, etc. Number 2, it's weird to solve for y here, isn't it? It's really strange because you already know what this is. The shape is a circle, radius 4. Is that a function? Are you sure it's not a function? Yeah, I think it fails the vertical line test like everywhere. But when you solve for y, you're putting that in function form. So if I were to solve for y here, you have y squared equals 16 minus x squared. And now I have to take the square root. So I have y equals 4 minus x. Did I do that right? No, I just did a terrible job, didn't I? I've done like the cardinal sin. I've taken a square root of a binomial like that? No. So when I'm solving for y, what's y actually going to equal to? Plus or minus square root of 16 minus x squared. Please take a moment to discuss with your neighbor. What is the role of that plus and what is the role of the minus?
Or the, what is it? The right. In the.
It's like a circle and it's like.
Yeah.
So please show me what the plus represents. Yeah, plus just represents this. The minus represents the bottom of that circle. So if I were to ask you to graph just y equals negative square root of 16 minus x squared, hope that it makes sense that that is just a semicircle. Radius 4. What do you think? With a positive one, it would complete that circle. When we have it all together, it's not a function, but we could take it apart so that it has 2 functions. You can see that does pass the vertical line test. That would be a function. It's only half of it. Anyway, I just wanted to give you that little tidbit before we continue with the packet. Speaking of the packet, we're not going to do the rest of the packet as I've given you. I have an adjusted packet that you are about to take possession of. I know. So in other words, you can disregard the rest of this unit package. We will be using this packet instead. Oh my goodness. Oh, it's fun.
We can drink my water.
Are you? How did you like to grab those last time? Very good. Oh, that makes sense. Did you completely step away from what you're used to?
It's like the long experience, it's like for all that. That's funny. I feel my dad is gonna be. Yeah.
We're on page, what was that, 15? Is that the first page you have there? 13. Okay. Um, okay, I'm gonna disregard a little bit of this. What do I want to do? Yeah, I think I'm gonna disregard that stuff. I'm actually gonna go to page 15. We've dealt with a circle all year that you know inside and out, haven't we? What circle is that called? Unit circle. The equation of that circle is equals 1. We'd love it. We'd love it, I hope. I'm gonna mess with it a little bit. Don't get mad. Is this still a circle? Because we know this is a unit circle. Is this a unit circle? No, obviously it's not. The equations change based on your knowledge of transformation. So translations, the slides, the stretches, compressions. I'd like you to discuss with your neighbor what's happened to the unit circle considering this change algebraically.
So it's like, yeah, like that. Like yeah.
It's like.
So like. The amplitude is fine. It's fine.
Will you please show me what's happening with the X in terms of gestures? Can you show me what happened with the X? Yeah, it's been stretched by a factor of 2. So instead of going from -1 to 1, it's going from -2 to 2. And of course, in the Y direction, it has stretched by a factor of 3, which is a different kind of thing that we've done. Yet oddly familiar, hopefully. So if you were to graph this, would it be difficult? I don't think it'd be difficult for you. And X would just have like a -2, +2, 3, -3, and then try not to make a diamond. If it looks like a potato, it's okay. Easy. The shape is called an ellipse, and that is a second, well, actually the third of our conic sections that we're talking about, isn't it? Parabolas, circles. We talked a little bit about circles, and now ellipse. What is the plural of ellipse? I don't think it's ellipsi. I like that idea. I'm not sure what the plural is, honestly, and I can't get anyone to get the right answer. It seems like it might be ellipses, but ellipses is a very definite literary thing, isn't it? What are ellipses when you're talking? It's a ... Those are ellipses. So is it ellipses
I think she's always.
for plural? Just ellipse? Okay, like deer and deer. I don't know. I'm gonna say ellipses for no particular reason, but no judgment here. And if you find out what it is, the plural of the conic section ellipse, please let me know. I've searched for it because I'm a nerd that way. Okay. Let's take a look at this. So here we go, some ellipse information. So notice the center of ellipse doesn't have to be at the origin, it could be anywhere, as denoted by the H's and the K's. Yes? Now, your book writes it like this. I've been writing it like this. When you do put your answers in your assignment, it's going to want it like this, just so you know, to save you a little bit of a hard time. So even though I'm going to be talking about it like this, like a horizontal stretch, it'll be separating the translation from trigonometry. Yeah, I don't know why. Now we are going a different path from what the book is saying. That's why I had to give you a new packet. So your book, the book talks about just like parabola has a focus, ellipses have 2, what's the plural of focus? Either foci or foci. Either one is correct. We're not going to be talking about foci at all for ellipses in this class. In your homework, if it asks for a foci, just punch it. I'm just kidding. Just I think you have to just hit enter and not answer it until it goes to the next one. Is that how it happens? You can skip problems like that. And you'll get full credit, and you won't see the full credit, but I'll mark you full credit if you skip those questions. So don't worry about it. But I don't want you to learn anything new. So anything that discusses a focus for ellipses, you don't have to worry about it. You may skip that portion. Pardon? Say that again? Yeah, you could, whatever it is you do to get the answer, or I don't know. You could like hit enter until it says, okay, I give you the answer. Or help me solve this problem, but you don't need to know that stuff is the thing. You don't need to know it. So there are two types of ellipses. Those that are stretched more horizontally and those that are stretched more vertically, even though it's kind of the same thing, isn't it? So your book is going to differentiate them with A's and B's. If it's stretched more horizontally, that means that A is under the X. If it's stretched more vertically, it just means that A is under the Y's. That's the only difference between A and B. A is always greater than B. It has a practical difference. Some vocabulary you need to know. Every ellipse, if is a circle an ellipse? The circle is an ellipse. It's like how every square is a rectangle. But so any non-circular ellipse will have a major axis that goes through the long side, and also has a minor axis, of course. And these are just the only two axes of symmetry. How many axes of symmetry does a circle have? One. Infinitely many, doesn't it? But ellipses only have two axes of symmetry. One, the longer one is the major axis, and the shorter one is the minor axis. At the ends of the major axis are 2 points. These 2 points are words that you already know. Starts with, oh, good guess. It's a good guess. Starts with a V. It's the other one. Yeah, it has 2 vertices. So this is a vertex. The other one is a vertex. Which leaves the question, what are the other 2 points? Like, what is... This is a minor axis, but this point would be... It's called a co-vertex. Oh, did you say lattice rectum? She told you about the lattice rectum? Nice. Helpful to draw the parabolas. And by the way, when you're drawing a parabola, at this point, I only care about 3 points: the vertex and the endpoints of the lattice rectum. This point right here is called the, what did I call it? Co-vertex. And there are 2 co-vertices. Let's practice some problems, shall we? Did I give you I think I give you all the information you need. Is this easy? Yeah, go ahead and do this problem. And just to check in with your neighbor, make sure that they're following along. Again, the same thing you are. Here it doesn't matter what's A and what's B. It does not. So how would you know this? Yeah. Like some five launch, five sites. Why? Yeah. It's over. You got it? Can I call on someone? Okay, I'd like to hear from Amir. What are the vertices? you mind if I just consolidate plus or minus 5 comma 0? Are we good with those? Thank you. Everyone, please show me the length of the major axis. Show me the length. Thank you for not doing this. Good, it's 10. And the minor axis is 6. Good, so I think that's enough to finish this. 3 and 3. -3, excuse me. We're not in polar here, we're doing the rectangular. And the goal of this lesson is really to just get the shape and the features of it. So we're not talking about any sort of definition or anything like that. Just the shape. Easy. Okay, this one. Huh. I give a moment to discuss.
We asked you. Oh, yeah.
Or 0, 3, 0, minus.
Why?
Basically, it's like.
No.
Yeah. Yeah.
But no, isn't it just like,
Why over?
Yes.
like,
Yeah.
it's you have to go back, it's like what we did in grade one with the.
What? Yeah. It should equal one, no? So divide by 9. Yeah.
Did you get it?
Yeah.
Check with your neighbor. I want to call someone in just a few seconds. Okay, so Hannah, what'd you do? Oh, but you did something.
Well, yeah, we started by dividing by 9.
Do we agree that that's a good start? Okay. So then you got x squared plus,
Equals 1.
okay. Is that all you did? You didn't get it further than this? Well, let's do it. Let's get further than this. What's the next step to get the vertices? Have to figure out like what's being stretched. Is this being stretched in the x direction, the y direction? What do you think? In the y direction? How far is Hannah? What do you think? By a factor of 3, right? We think about this as y over 3 squared. So, which means that the vertices are,
0.3 and 0.
nice, I'm gonna put those together. Nice, thank you very much. Would you please, everybody show me the length of the major axis? Interesting, I'm seeing 5s and 1s, 3s and 3s, but no 4s and 2s. Oh, I see the 4 and 2, okay, thank you, I missed it. Yeah, it's 6, and of course the minor axis is 2. Yay, I didn't see any of this. Interesting, it's 2, okay. It's nice and efficient. So to graph this, I know this must be the most challenging day of the whole year. Did I do that right? Yay. By the way, another way to do this that's perfectly valid would be to take this and find the intercepts. For instance, how do you find like the x-intercept of any? You make y equal to 0. Do you see what happens when you make y equal to 0 just in your head? Do you see what happens? You get x equals plus or minus 3. Right? Did I do that right? No, sorry, when you make as for the x value, so when you make y equal to 0, you get x equals plus or minus 1, which matches what we have. And to find the y-intercepts, so make x 0, you get y equals plus or minus 3. So you get an hint of what it looks like straight away. without even putting it into the form of the unit circle. But yeah, usually we set it equal to 1. So Sahana, thank you for dividing by 9. That is essential first for most of these. Oh, I wonder what's happened here. Should I expand that x plus 4 squared? No. You know the center of this ellipse?
Which one did you use?
We actually the square, but
Oh, you're right, you're right.
No. It's all about making things check on the x direction or y direction.
plus B.
So that doesn't need 3? Yeah, yeah. No, that's good. Yeah, because then you get 1.
You have it?
How'd you do?
Okay, so folks, if I were to remove these, it would just be a circle radius 1, wouldn't it? If I were to remove those denominators. But I can't just change the problem like that. So it's still kind of a circle radius 1. It's just in the x direction it has to be stretched by a factor of 3. So in other words, from that center, I notice I marked with an open circle because it's not part of the ellipse. You can or you can't. I'm not going to mark off if you put a dot there. Just going to go over 3, which means I'm over here at -1. And then over at -7. Do you have those 2 points there on your graph? And in the y direction, I'm stretching it factor of 4. So instead of going up 1 and down 1, it's going to go up 4 and down 4. So from -2, I'm going to go up to +2 and down to -6. And then you do your best not to make that a diamond, a rhombus. There we go. Yeah. Okay. Any questions? I went 4 up. Because it's being stretched by a factor of 4. Remember, this is also the same thing as well.
Oh, that's it.
Well, the whole thing is square.
Right.
So it's stretched by a factor of 4.
It's not. It's like already like.
Oh, this is interesting. Yes, Holden?
I was gonna ask, so
Uh-huh.
are we allowed to keep that center point? On it?
Keep it at, for what?
Like, you don't have to, it's like, not.
Oh, if you like it, is it okay to leave it there once you graph? That's fine. I'm looking for more of the shape. Good question. Any other questions about that one? Okay. Ooh, what 3 words do I want to hear? Complete the square. I'll give you a moment.
Yeah.
Make sure you're doing this right. I'm gonna be calling on someone for this.
Might be on.
Or the side.
Well, yeah, you divide everything by.
Yeah.
And then. Yeah.
Yes. You should be able to. Yeah, this one's a little bit wonky, isn't it? Yeah. Nice.
Yeah, you're right. Yeah.
Yeah.
Are we ready? 10 seconds before I call on a lucky young student. Make sure you've confirmed your answer with someone. No, did you have a question, or are you hoping that Destiny will call on you? I appreciate that, but I'm leaving this up to Destiny. Thank you.
Not here, I believe in that.
I didn't want to think on a full purpose.
Oh, it's up to Destiny though. We'll see who which lucky student it is. Okay, folks, I'd like to hear from the one and only Henry. What to do first?
Alright, first second leave square.
Okay.
Like 6, both sides.
And why did you add 6, just out of curiosity?
B over 2.
There's a B here?
I didn't know. I thought it was the half. So it would be for a quadratic function, but
So we have 1, 2, 3, 4 terms. Okay, so you're looking at the third term? Okay, then what do you do with that?
I divided by 2.
Okay, and then?
So that was 6, so I had 6 to both sides.
Okay, so when you complete the square, you just cut that B term in half, is that right? Oh, and then you have to square it. But even before that, you're onto something here, but even before that, there's something we have to keep in mind. Leading coefficient of that quadratic term must be 1. So should I divide everything by 3? I can divide everything by. Yeah, let's factor it out. So Henry, you gave us a process, but there was a little bit of an issue with it, unfortunately. Oh, what should I do with that plus 9? Yeah, let's move it to the other side. It's not hurting anybody. So equals -9. So now let's do what you were talking about. No, it's -4.
So for 2.
And that turns to 12.
Are we okay adding 4 here?
Yeah.
So would you please show me what I have to add to the other side? Everybody, would you show me what I have to add to the other side? Yeah, it's got to be 12, doesn't it? It looks like we're adding 4, but.
Oh, yeah.
Sorry. So I have to add to the right. Henry, I'm sorry, I gave you the one that there were so many pitfalls here. And clean this up a little bit. X squared plus 3 times y minus 2 squared equals 3.
So that would have worked too.
Oh, that's true. Probably would work. Yeah.
Okay, but let's say with different numbers, would that work?
It'll always work. The question is which one will always lead to usually lead to a cleaner process. And I think factoring it out will normally do that. But you're right, just dividing everything by 3 would have been fine. Would have been fine. And we would, I think we wouldn't have been left with that 3 here, because now we still have to. Did you divide by 3 first? Like, from here, you divide by 3? Yeah, we divide by 3, so we have x squared over 3 plus, oh, that's nice. Y minus 2 quantity squared over just 1. I'm just going to leave that equals 1. And let me write that like a normal person might. That's fine. Because then I can see that you think, okay, the y direction is stretched by a factor of 1, but it is unnecessary. Okay, so do we have a circle? Definitely not a circle. It's an ellipse. It's a stretched circle. In the x direction, we're going to stretch it by a factor of √3. Does that make sense? Because we have to think about this as inside, inside the function. So what's happening directly to that x? So it is being divided by, yeah, √3. Would you just check in with your neighbor for a decimal approximation for the square root of 3? See what they have to say about that.
1 point.
Yeah. It's like 1.4.
Okay, so what is it? Square root of 3 is approximately 1.7. It's 1.732. Okay. So to graph this,
No, I like.
I think we do this, and then in the x direction, we go left and right. Square root of 3.
Oh.
And then in the y direction, we just go 1.
Wait, isn't it?
Yeah. Good catch.
Let me see if I could save my ellipse. There we go. Look at that. Like nothing ever happened. I still have my beautiful ellipse in place. Good catch. Any questions? Oh, no, that's a dash. I'm just kidding. That's definitely negative. Thank you. Okay, now it's all good. Okay. Any questions? Yes, we have.
It's only one. Wait, sorry, how do you get the Y in it? Or,
Well, it's always a transformation of the unit circle. So without anything in the denominator, that radius in quotes would be 1. The fact that there's nothing down here just means that in the y direction, just wasn't stretched, just goes up 1 because it's downward. In the x direction, which it's being stretched by a factor of 1.73. Or squared in the Any other questions? The time is now 2:39. At 2:43, we'll resume. If you have questions, you could ask one another.
Also, you
can kind of stand up, stretch. If you need to go, you can go.
yeah, so he's not great. He's not great. He wants. No, he does.
Oh, wait.
For a second.
Yeah.
Wait, but did you guys do it? Yeah.
I didn't finish it.
No, but we had Mr. Road and he was the actual full time and we did baby through adult. Like adult, yeah, so I don't know if this is. Well, yeah, cause I. Well,
There is an
that's
extra
just
one,
like-
showing you right. No, I just, I agree with what you're saying.
That's subverted.
No, it's like, we're like hit a break. No, no,
Like,
you-
you
you're
really
like
up and
absolutely
like
spot
one
on
thing
with
that
your.
says another grade. That's other homework too.
Alright, so when I checked to see if you were
Without
correct, was I checked,
proper
so this,
cram
you,
it all.
when you said was correct, this would be.
Well, it's
right? So I checked for the X intercept here, and I got. an X.
Also, the,
So
like, research paper.
that's that.
Oh, yeah, that's.
Wait, like, so which ones are right?
One,
did not-
one comma zero,
Which graph is right?
oh, just this is for this.
Oh,
Yeah, yeah, yeah. No, no, so
And there was like
you're
that
absolutely right.
owner, and there was like one.
It should-
page
yeah,
that
and
was
I'm pretty good at
so it's like so-
I got it.
Yeah, like, yeah. Was mine.
Yeah, like before, yeah.
So what you said.
Wait, what?
It's not good. I stuff like nothing. Yeah, I always.
What's your? Mine is just on the. Okay. Oh. Yeah, I saw.
Oh, this one's actually. the
Did you
hardest.
make Coca-Cola? So, yeah.
Just change it to wine. Yeah.
Got a.
And I just-
button right. Wow. And I was into something else like. No, it's like Asian. Yeah, there's like nothing interesting. Like, I don't know. Cause none of it like. Seems like.
Sorry.
Why not?
Yeah.
Watch for, we'll find us.
They get rid of this negative. Get rid of it. Solve it.
Oh, yeah, yeah.
Right?
Oh, wow. The ET bar. Like, I would have.
Nice. Fine.
Probably is.
No, but like last time, it's pretty much like a circle. Because this radius is, oh no, the radius is.
Really?
Yeah, I'm just trying to call.
That was almost.
Like, and this shape is.
Okay, that looks.
Okay. Let's finish this off. You could do this one on your own. This one. Go ahead and put this into a form that's easy to graph. I will call someone to help me with that. And again, you're just putting it into a form where it's a little bit easier to graph, something that we're used to seeing from today. And check with your neighbor once you're done, or if you're stuck, check with them.
Looks like.
Square both sides and says 16 over. I just got the radius for. I mean, the shape was very similar.
Yeah. It's just.
Yeah. Okay, I'm fine with that.
There's something.
No, because you, when you do that,
Oh.
oh, you kept it at 4.
I
Got
kept
it.
4, you know.
Oh, you did it. Yeah, okay, so that was like.
Okay, so.
What is keep it at 4?
Did you get this? Yeah.
Brian had a bit more.
10 seconds.
Was more than. I mean, that's right. Oh, yeah, time.
You draw those marks.
Okay.
It's like-
I'd like to hear this. So, ready or not? Henry, do you want to do this one, or should I call on someone else?
I could.
Okay.
All right, first off, I just combined the terms, so like 4x squared minus 8x plus y squared plus 4y plus 4 equals 0.
So you kind of reordered them a little bit.
Yeah.
Plus 4y plus 4 equals 0. Okay.
And then what I did was I did y plus 2 squared, so in like parentheses.
Oh, so you recognize that that's already a perfect square. Nice. Okay.
And then what I did was I pulled out the 4 from the 4x squared minus 8x.
Okay.
So it was 4 times x squared minus 2x, and then like a spot for completing the square. Which I found was 1 on the left side, and then on the right it was 4.
Why is it 4?
Because you have to multiply 1 times the 40.
Nice.
Which was then I divided everything by 4. So x minus 1 squared plus y plus 2 squared over 4 equals 1.
Plus y plus 2. Okay. Over 4 equals 1, you said? Are we good with this? From here, are we set for success? Perfect. Thanks, Henry. Nicely done. I'm not going to answer the rest of that, but I do want to give you a chance to talk about these two.
Let's draw something.
These were negatives out of it.
Yeah,
that's what you do.
y squared equals 4 minus
We're drawing fine.
That's what we call that.
Square.
Yeah.
That's a good idea.
I think that's the next.
But it's also. So.
What's on here?
Let's go.
Oh, sure. Here?
Nice. First one.
You should be graphing this. If you have no idea what to do, check in with your neighbor. If they don't know what to do either, you have other people around you.
I think I'm like about to get there. Like this, like it'll look like basically when you ask for you're stretching it, but it's just 4 times x squared. You have to like shrink it. Oh, I guess, yeah. But actually, I would get it.
So.
Don't know why. Yeah.
I think because this is negative there. So, and not the positive.
Yeah. Yeah. Yeah.
Oh, really? Probably.
You
not.
remember?
Wait,
Oh,
is that like this?
yeah. So it's only the negative.
Genius. I think it's.
Are we ready?
He's like, instead of longer than higher, they like, I swear it like.
You thought this was my heart.
Okay. I need some help. Nico, can you help me with this, please? Thank you.
So the way that I originally done it was instead of writing f of x, I wrote y is equal to negative square is 4 minus 1.
I like what we've done so far. But what happens to that negative? Yeah. So, so negative times itself, right? We're just squaring both sides. Nice. Okay.
Move the 4x to the same side as the y squared.
I'm digging it. Okay.
So, y squared.
Okay. Oh, so it's an ellipse. Okay. And is it a full ellipse? How did you know this? Okay. Exactly. If we started here, right, at that last one, which very nicely done algebraically getting there. If we started there, that would be the full ellipse. But think about if you were to solve for y, it would eventually give you the plus or the minus. We've been given the minus, which means, like you said, we're just taking the bottom of that ellipse. That's it. Does that make sense? So is that easy to graph? I think so. I think in the y direction, we just stretch to -2, and then these are ones, something like that. It's a happy little graph. Okay, cool. Is there a twist like that for this last one? We make sure to discuss with the neighbor. Oh, yeah, first. Here?
It's like there, yeah. I'm like,
Huh?
Why is it? It's,
Why
why is it like optimal?
well, this would be flat.
Yeah.
But it's gonna go backwards. And solve for one.
But like, sometimes not if you like each goes to kind of.
That's more like this. I just like.
Oh, so all
Ooh.
all the Y.
In this case. Almost. No.
It's myself, but-
This is. It's like. This. Yeah, I know. I think you want. I think you can. But let's see how this.
What else would we got? Good.
Would you please show me what the graph would look like in the end for that last example? Show me what it looks like. And remember the last one was y equals negative. This one is x equals positive. Yeah, so x could only be positive, can't it? So it's not the full ellipse, it's only the right side of it.
I always.
I'm gonna give you some time to dig into your assignment. I think you'll be able to do a few of them. Nicely done today.
And